Hi everyone, it's me, Miss B, and in this video we are looking at the cumulative practice problems for Unit 2, Lesson 7 of Illustrative Math Algebra 1. So, on these directions we have that we have to justify our thinking as we answer each question and show our work in order to earn full credit. So we're going to do just that. The first question here is to match each equation with an equivalent equation, and some answer choices will not be used. So we are going to use A, B, and C, but 1, 2, 3, 4, and 5 may not be used. Now, an equivalent equation, just to remind you, is one that has the same solution. And any two equations that have the same solution can be manipulated to literally just be the other equation. It just might take more steps for others than it does for some, and it might not be intuitive, but they all can technically be reorganized and rearranged to be equal to each other or be the exact same. So we're going to look for ones where we might have had those steps gone. So let's actually look at this first one here. 3x plus 6 equals 4x plus 7. So I want to see if I have anything here that is similar. So I have 3x plus nothing makes 4x plus 7, but that's not right for that one. 7x equal to 1, maybe not. But I think maybe this one, 3x, and still has 4x. Because here for number 2, it's 3x plus 18 equals 4x plus 7. Same as number 3, the only thing that's changing is what's next to the 3x, and everything else is staying the same. So 2 and 3 aren't going to work, but I think we can actually make number 4 work. So it looks like they're just moving this number, the 7, away from this side, the 4x. So we would subtract 7 from both sides. And what do you know? That would go away, and here we would get 3x minus 1, because 6 minus 7 is negative 1. So I am going to match this one here with, oh, that's the wrong one, with this one here. So A goes with number 4. Now B and C, obviously they're all going to have similar numbers and things in them, but B and C, here it looks like my first step might be to actually distribute. So if I distributed the 3 to both of these, let's see what that is. I'm going to do this work in blue just so it doesn't interfere as much with the one above it. This would be 3x, and 6 times 3 is 18. Now, when I distribute, that's not necessarily a step in the order of operations. That might be involved in like simplifying our parentheses, but it's not going to change the value of the left-hand side of the equation. So since I'm not changing the value, I don't have to do anything to the right, and 4x plus 7 can stay the same, and that is okay. And that actually was one of our options, so let's match that one up. This should match with number 2, which is straight across from it. And I'm going to make the line for this red one here a little thicker. I like using the thicker lines for matching, and I kind of just forgot about that. Okay. Now for the very last one, it looks like they reorganized the variables together. So 4x and 3x are both on the left, and 7 and negative 6 are on the right. Let's combine these, because I think I know which one this is going to be. But let's still see if we can just combine our like terms, because that seems like our most likely process here. So 4 plus 3 is 5, 6, 7x. And then 7 minus 6 is just going to be positive 1. So I'm going to have 7x is equal to 1. And that's the answer that we have down here on number 5. So we're going to connect these here, and that's how that would match. They did say match it with an equivalent one. So the other questions here, they did tell us might not be used. We're not going to match them with multiples. From there, we're going to go to question 2. So my says that equations A and B have the same solution. And then we want to look at which statement explains why this is true. So we're going to say that my statement is true, that they have the same solution, but we want to know why. So what are they actually doing? We might think, hey, take the -3 and distribute it through. But if you look down at the next equation, it doesn't look like we actually distributed through the -3. Instead, it looks like they're dividing by -3 on both sides. That's a balanced move because even though it's changing the value on the left, we're changing the value on the right in the same way. So let's look at our options. Our options are adding 3 to both sides gives that. Nope, it was not adding. If I applied the distributive property, that might seem like what we should do, but it does not give that answer. We did not subtract both sides. We divided both sides by -3 to get that answer. That's it for question 2, just identifying what kind of step they were doing. Number 3 is asking, is 0 a solution? And then explain or show your reasoning. So in order to do this, you can do either, but I'm going to explain some reasoning here first. So I'm going to draw a little square here to kind of block out some of my numbers and color in. Okay, so, but I get to move these around. So if I plug in 0 and multiply it by something, 0 times anything will make that number 0. So normally I would like cover this up with my finger, but I'm going to use this piece here. So if I plugged in 0, that would take this term away, and I would just have 10 on the left. And if I also plugged in 0 on the right, it would take that term away and create 0. And so I would just have 10 on the right. So that would be showing my reasoning, which would mean that, yes, these are both equal because they should both equal 10. But what I'm going to do is now actually show you that we can work that out. So if you're not sure how to explain those things, you can actually just do your process of solving equations on whatever we have here. So I'm going to start by subtracting 10 from both sides, but I guess I should actually start by putting my divider line here. So minus 10 means I have to minus 10. Those will cancel to go away, and I'll have 2x is equal to 4x. So I'm not done, but I'm getting there. We're going to subtract 2x from both sides because I want to put my variables together. So I'm going to put them both on the right-hand side. I like to put them where my larger number is, or the largest positive number. So that's going to leave us with, on the left, 2x minus 2x. They cancel out. They make 0. And then on the right, we would just have a positive 2x left over. One more step to find x by itself would be divide by 2, and this would mean that 0 is equal to x. So we could actually solve and find that 0 is the answer. The other way to do this is to plug 0 in and see if we get something even on both sides. I was just doing that as a sort of visual before, but we can say 2 times 0 plus 10 equals 4 times 0 plus 10, and then show that this is 0 plus 10 equals 0 plus 10, or that 10 is equal to 10, and that's like a check step. So a couple different ways you can try to use words and explain that, like plugging something in here would take that term away. You can actually show solving the equation, or you can show plugging in and that it gives you something that's equal. But that's going to be it for the front side. So let's flip over. We got a couple pages on this one. So question 4, Kieran says that a solution to the equation x plus 4 equals 20 must also be a solution to the equation 5 times x plus 4 equals 100. Write a convincing explanation as to why this is true. Okay, I'm going to be a little bit long-winded with this. The simple answer is that these two are equivalent equations because they multiplied the first equation by 5 on both sides. I am going to say something a little bit more long-winded. I'm going to say multiplying both sides of an equation by the same number will keep the equation balanced. Since it will keep the equation balanced and produce an equivalent equation. Sorry, I meant to put that part in there because part of my explanation is going to include that. So now I can say since x plus 4 equals 20 is multiplied by 5 on both sides to create 5 times x plus 4 equals 100. They are equivalent equations. And must have the same solution. This is more of an explanation that I might have students in my geometry class write when they are doing proofs. So you always have to explain why the property you're using means that you're allowed to do certain things. And so we are really just proving to someone else or convincing someone else here that these would both be the same by saying, well, yeah, if you multiply both sides by the same thing, that's going to keep it balanced. It's going to create an equivalent equation. Our definition of equivalent equations, or at least the one I use with my class, is that equivalent equations have the same solutions. So since all we did here was multiply both sides by the same number, these have to be equivalent, and so they're going to have that same solution. It's a little wordy, but it is good practice at making explanations for mathematical concepts. For question 5, we have a word problem. So the Entrepreneurship Club is ordering potted plants for all 36 of its sponsors. I'm just seeing some numbers here. I'm gonna underline some things that look important. One store charges $8.50 for each plant, so $8.50 for each plant. And then I see delivery fee of $20. The equation 320 equals x plus 750 times 36 represents the cost of ordering potted plants at a second store. What does the x represent in this situation? Well, one of the numbers I underlined here, or some of the other numbers, we can use to kind of fill some of these blanks in. Sorry, I wanted to zoom in enough here. There are 36 sponsors. So that tells me that this 36 is that 36 sponsors. Now they're going to have a price per plant and then a delivery fee. So they're going to be ordering 36 plants. It would make sense that the 750 is the price per plant. So this value here is going to be my delivery fee. And then the 320 would be the entire cost. So I'm looking for the delivery fee at the second store, and that answer is B. The cost for each potted plant at the second store, I'm going to just put a rationale here. That should be the 750. The total cost would be the 320, and then the number of sponsors would be the 36. So all those other numbers had things that they represented. The delivery fee at the second store would be the X. Okay. Now for question 6, it's which equation is equivalent to the equation 5x plus 30 equals 45? One of the things I like to do for these, when it asks me which equation is equivalent, I like to just look at my original equation and then try to solve that, because oftentimes the steps I would take in solving this equation show up as my options for equivalent equations. Every step in our solution process will produce an equivalent equation. So let's take the time to do a little bit of that here. I'm going to subtract 30 from both sides. This would be 5x equals 15. And then if we divided both sides by 5, we would get that x is equal to 3. So let's see if 5x equals 15 or x equals 3 is one of our options. Now they are not options, but that's okay because we didn't do anything that's necessarily wrong. You can always use the actual solution and test it in all of your other options to see which ones make something true. But I know that 5x is not equal to 75 because 5x should be equal to 15. So I'm going to cancel that one out, not cancel it out. I'm going to cross that one out. That way I just know I'm not supposed to be using that one because I already know it's not going to be true. The rest of these equations all have something in common, and that is that they are leaving the 45 on the right-hand side. So they're not actually changing the value. They're probably just going to rearrange something here. So that means we can look at our 5x plus 30 and decide, how can we rearrange this? And what I see is that both of these pieces are divisible by 5. So what we can do is factor that out, basically do the reverse distributive property. But that process of pulling out a number that multiplies into both of them is called factoring. So if we pull that number out, or divide it out, or reverse distribute, 5x would just become x, and 30 divided by 5 is going to be 6. So that is actually going to be option D right here. And you can even double check by redoing the distribution to see if it works. And it will. So I'm going to say D is my solution here. And this was, I'm going to say what they did. So I would say factor out, and then I'll write in here reverse distribute. A 5 from the left side expression. There we go. They're equivalent because they factored out or reverse distributed a 5 from the left side expression. That brings us to question 7, which is the Environmental Science Club, and they are printing t-shirts for their members, and there's 15 members. The printing company charges a certain amount for each t-shirt plus a setup fee of $20. Now they're going to give us a total, which is $162.50. How much do they charge for each shirt? So I want to know this question right here. So I'm going to make sure that I answer that with my math. So 15 members, and it charges a certain amount. I'm going to use X for this, even though you could use S for shirts. But actually, since this is a price, maybe we'll just use P. So the number of shirts that they're going to order is 15. But we have to multiply that by the price of each shirt, and then we have to add the setup fee to it, which would be $20. This is going to give you their total of $162.50. So, using a calculator, or just some mental math, but I always like to check myself, especially so I don't make any big mistakes on the videos I make for you guys, which I make some small ones now and then that sometimes I don't catch even until later. But I'm going to start by subtracting 20 from both sides. So that would leave me with 15 times the price is equal to 142.50. This is where I'm going to use my calculator to divide, because I have to divide both sides by 15, and I don't know that I could do 142.50 divided by 15 in my head. But that will leave us with P equal to, and then this is where my calculator comes in, 142.50. We're going to divide by 15. This says 9.5, but I know it is dollars, so I'm going to say 950. And we can say they charge $9.50 for each shirt. And there we go. That is my answer as a sentence. We have, I believe, one more page of stuff, but let me double check. We might have one after that. No, just this last page. And there's only 2 questions. It's just this one is very large. So we're going to do question 8 here. This graph shows a relationship between temperature in degrees Celsius and temperature in Fahrenheit. So we want to mark the point on the graph that shows temperature in Celsius when it is 60 degrees Fahrenheit. That's our first task from part A. So we are going to find Fahrenheit, degrees Fahrenheit, that is on my horizontal axis. And I am going to find 60 degrees Fahrenheit here. Found 60 degrees. I'm going to follow that upwards and then mark that point on my graph. But I'm not going to do it with my laser pointer. So that would be right there. Okay, I marked that point. Now we want to mark the point on the graph. So sorry, this was 60 degrees Fahrenheit. Maybe I'll use a different color for the next one. Mark the temperature, or mark the point on the graph that shows the temperature in Fahrenheit when it's 60 degrees Celsius. So Celsius is on the vertical axis, which means along our vertical axis, I see 60 right here. We are going to take that and follow it over and land right here and put a point there. So let me make my point pretty big here, and then I'm going to erase this chunk. Don't need that line. So now I have my 2 points. Okay, for part C, it says water boils at 100 degrees Celsius. Use the graph to approximate the boiling temperature in Fahrenheit, or to confirm it if you knew what it is. I know what it is, so I am going to use this to confirm it and then just tell you what number it should be based on where the estimation looks like. So 100 degrees Celsius, and maybe I'll do this one in purple just to have something color coded here. 100 degrees Celsius, we're going to take this and drag it all the way over here, and it's going to be not quite on 210, because you can see down at the bottom here, we have 200, this in between is going to be 210, and then 220. It is very much not quite exactly on 210. It's a little bit after it. I would say it's here. And that actually works for what I know the boiling point to be in Fahrenheit. The boiling point in Fahrenheit is 212 degrees. So I would say 212 degrees degrees Fahrenheit. Okay. Part D, the equation that converts Fahrenheit to Celsius is C equals 5/9 times the quantity F minus 32. Use it to calculate the temperature in Celsius when it is 60 degrees Fahrenheit. And this answer will be more exact than the point you found in the first part. So let's just use that function. It is 60 degrees Fahrenheit. So they're telling me basically that F is 60. So C equals 5/9 times 60 minus 32. So order of operations, or PEMDAS, this tells us what order we can do everything in. So just as a refresh, P is parentheses. Probably spelled that wrong. E is exponents. M is multiply. D is divide. A is for add. And S is for subtract. But we do multiply and divide from left to right, and same with add and subtract from left to right. So that means when I'm simplifying this expression here, I need to do the parentheses first because that's the P in PEMDAS. So let's do 60 minus 32. And then we'll do a multiplication. Technically, you can distribute this through, but it's going to be a little wonky. So I'd rather just do 60 minus 32. That'll give us 28. So we'll say C is equal to 5/9 times 28. And if you're not sure how to do this on a basic calculator or one that can't do fractions, you can still multiply by a fraction. I'm using a basic calculator right now, which is why I bring this up. But you would just multiply by the numerator, or the number on the top, and you would divide by the number on the bottom, or the denominator. So I'm actually going to do 28 times 5. And then divide that by 9 to get my answer. And my calculator says that this is 15.55, repeating. It just goes 5, on forever. And this would be, oh, excuse me, got a yawn there, degrees Celsius. And that would be the answer for part D. And that's all for question 8. So we have one question left here, question 9. This is one, selecting everything that has the same solution. So everything that has the same solution as 2x minus 5 equals 15. This looks pretty similar to one we did earlier, or maybe on a different assignment, but let's just go with it. Actually, did we have this one? 2x minus 5 equals 15. Oh, no, it was the 2x plus 10. Okay. I think that might have been another question on the previous homework. Either way. I like to start by trying to solve the original equation and just seeing what works. And sometimes my steps actually are some of the options. So I might start by adding 5 to both sides. 2x makes 20. And then divide both sides by 2. That would give me that x is equal to 10. And I can also use the fact that x is equal to 10 to plug in and solve for some things here. So I do see 2x equals 20 as option B, so I am going to circle option B. I don't see that x equals 10 as an option. I know 2x is not 10, it's 1x. But we have some other things we can do here. The next one here looks like they reverse distributed and tried to pull out a 2. But they're starting with 2x minus 5. And negative 5 can't divide by 2. So we're going to leave that one alone. Or not leave that one alone, we're just going to leave that one. That one's not an answer. D actually is an equivalent equation here, because instead of adding 5 to both sides, we could subtract 15 from both sides, and that would create D. And likewise, E would work as well if we took the original equation and we could multiply it by 2, then that would give us E. Yeah, and then F does not actually work because they're leaving the 15 alone, but they're switching the place of the 5 and the 2, and that negative sign needs to stay with the 5. We can't trade places without moving the negative sign with it. So that is everything for this homework assignment. So hopefully that helped, but sorry, I gotta cross that one out or it's gonna bother me. So a little bit of a longer one, but hopefully that helped you understand some of these things, or at least why I would choose to do them that way. So again, this is the Unit 2, Lesson 7 practice problems for Illustrative Math, Algebra 1.